Alright guys, let's do one final video on glaciers, and here I want to show you pictures and graphics and images and things. There's a diagram like this in your class notes, but I decided, it's very small, it's kind of hard to look at, and that we'd be better off just kind of skipping to pictures and things. So here we can see a glacier, and we'll talk about some of these other features and items in the image, and we'll look at some actual pictures of those. But one of the observations that we can make about this diagram is that we have our terminal moraine here. This is our end moraine. This was where the glacier was. So this represents the extent of glaciation, meaning that the glacier was once right up against this end moraine. A couple times now we talked about how Long Island is a large terminal moraine. So the glacier had to have made it to here. Now, one of the common misunderstandings with glaciers is that, well, if this is the terminal or end moraine here, the glacier had to have made it this far, and this represents how far the glacier had to have gone. But the glacier didn't move backwards, and that's something that sometimes confuses people, adults too. The glacier didn't go backwards, it's that the glacier was melting back. So it's not that the glacier reversed direction. The glacier is not going to go back uphill or anything, but the glacier is melting, and that could happen because maybe the climate is getting warmer, or there's some other environmental change. And in any case, it's getting warmer, and the glacier is melting for some reason. And as the glacier melts backwards, we see the terminal moraine being left behind. The terminal moraine is, again, unsorted sediment. We have a mixture of sediments. We have boulders, cobbles, sandstone, clay, everything all kind of mixed together, and it's unsorted. Now we'll take a look at some of these other features. The area between the terminal moraine and the glacier, we have the ground moraine down below. We have features called kettle lakes, and we'll look at these more specifically, but a kettle lake is basically a lake that formed from a large block of ice, and that large block of ice basically sank in the ground and melted. Imagine an ice cube in sand, and eventually that ice melted and formed a lake. These areas are often relatively flat, and we see braided streams very often, glacial streams, braided streams associated with the melting of the glacier. We also see features called drumlins, which are these kind of rounded hills. And we also have what are called eskers, which I mentioned in another video, and are basically the remains of a stream that was flowing through the ice. So let's take a look at some of these features in more detail. First of all, here's glacial till. Glacial till is just the sediment from a glacier, and we can see that it's very unsorted. We have large boulders and cobbles all mixed together with sands and silts and clays. There's no separation by particle size like we would see with water. When we have a stream or a river entering a lake, we have those large particles at the bottom, and then it gets progressively finer as we move toward the top. We don't see that here, maybe a little, but not much. And what we do see is basically the large rocks tumbling out, but that's due to gravity. It's a little different. But we have a mixture of sizes. It's not sorted, and we call that glacial till. Where we live, the soil is glacial till. Again, it's transported soil from Canada and points further north. We don't have the soil that formed in place. That's residual soil. You would have to go to a different place further south where the glaciers never made it to, like parts of New Jersey or further south, Florida, for instance. Let's talk about eskers now. So an esker forms from a river that was flowing through the ice. The ice is somewhat like Swiss cheese. It's full of holes, and the water flows through those holes. And what we have is rivers and streams flowing through the blocks of ice, and they carry sediment. When that glacier melts, the sediment that the stream was carrying gets deposited, and we have this almost snake-like structure left behind, or tube of sediment. This was the material that the stream was carrying, but the stream is no longer there. The ice is melted away, and this is the sediment that the stream was carrying as it traveled through the ice. We call that an esker. Here's an actual picture of a stream that was flowing through a glacier, and we could see these caverns. This is where the ice, where the water is flowing through the ice. We could see the stream flowing through. The stream's carrying sediment. Eventually, though, all of this ice goes away and the water stops flowing, and we end up with the remains of that stream called an esker. So here's an esker here, the remains of the stream that were once flowing through the ice. Another glacial feature we see are what are called drumlins. And drumlins are these kind of rounded hills. They are steep on one side and a gentler slope on the other side. And the steeper hillside represents the direction the ice is coming from, and the gentle slope is the direction the ice is moving toward. If we were to look at it from above, topographic view, we would see it's steeper on this side, more gently sloped on the opposite side, right? So this shows the direction of ice moving, kind of like glacial striations and chatter marks. This gives us a direction that the ice was flowing toward. Here's a picture of an actual drumlin. We can see steep side on the side where the ice is approaching, and then a gentle slope on the side that the ice is flowing away from. Here's an aerial picture taken from an airplane of a drumlin, and we can see these hills where it's steep on one side and gently sloped on the other. And you might see many of these drumlins. This is actually in New York somewhere. We actually have quite a few of these drumlins. You just don't really notice them because they just look like a hill. And you know, unless you really get in an airplane or look at satellite images, they're kind of hard to spot. They're often covered in trees and forest. They usually don't stand out. They just look like a hill, and we really don't pay much attention to them most of the time. But these are evidence of glaciers. And again, we can get a sense of the direction of flow of the ice. And this is evidence that this area was under ice, thick ice, 1 to 2 miles of ice during the last ice age. And we can see that the glacier had to have come from the left side of the image and to the right side of the image. The steep side of the hill is where the ice was approaching. The gentle slope is where the ice is moving toward. Another feature is the Kettle Lake. The Kettle Lake is another glacial feature, and we find these still around this area. We have large chunks of ice. The ice eventually melts. As the glacier is melting backward, it leaves these blocks of ice behind. Sometimes they call this dead ice. The ice gets buried. Eventually it melts, and we have what's called a Kettle Lake, these deep holes filled with water. And here are some kettle lakes here. They might just look like little ponds, and they basically are, but they're quite deep. So these might look shallow, but they're actually pretty deep. You know, imagine a large block of ice, and then that large block of ice eventually melts and forms these holes, these deep ponds. We call these kettle lakes. Here's the outwash plain. The glacier is melting backward. We see braided streams and a lot of sediment. This is the ground moraine here, braided streams. Okay, so those are just some of the glacial features that were in the final part of the notes. And I think the only thing that we have left to talk about in the note packet is Niagara Falls. And then this unit is largely done. So we'll probably finish with weathering, erosion, deposition this week. Again, we'll have a quiz at the end of the week. I don't intend to do large unit tests while we're not in school. Midterm indefinitely postponed. And after weathering, erosion, deposition, we'll do Earth history. And when we finish Earth history, then we'll be on to astronomy, and that will be it for the year. And we'll see what happens with our time off and how this all shakes out. So good luck and be well.